Cool. So I think you guys already know enough about me, but here's a funny picture so we can all get comfortable. I like to lounge in the sun and wear rompers and smoke cigars, right? You guys can follow me on Twitter if you want. I work at Amazon, as mentioned. I work in the retail site. Now, as you can imagine, there are a lot of teams on the Amazon retail site, right? It's not just one team. There's a lot of work that is involved in creating an environment where those teams can contribute autonomously and quickly. And that's what we're going to be talking about today. So, come just, do any of you work on some kind of product with a user interface? Just most of you? All right, cool. And there are multiple teams on those products, or is it just one team working in that interface? Do you have multiple teams? More than like 5 teams? More than 10? 5. Okay, cool. Google or Facebook people here? Anyway, are you guys using anything other than a monolithic type of architecture? Is anyone doing something other than a monolith? No? So to explain, by monolith I mean a single code base, or you're merging all your packages together into a single release? No? Okay, cool. Well, monoliths aren't bad. They're great, they're easy to set up. They're much less complex than what I'm going to talk about right now. They're easier to end-to-end test and make sure you're confident that it's going to work in production, catch bugs before they get to production. The problem we run into is that they don't scale very well. After a certain amount of time, a code base grows and we start to see diminishing marginal returns on developer efficiencies. It's difficult to innovate. Those business boundaries that you defined earlier on, they start to get crossed because nobody can really enforce anything in the front end. So we got to release our code in some kind of release train. That's just a big pain in the butt. I don't know if anyone's dealt with that. You push your code, and another team pushes their code, and it all gets released on Thursday. And then this team goes and screws up and introduces a bug, and so they roll back everybody's changes, and it's just extremely inconvenient. And also, often technology is prescribed, right? If we're all in one environment, we're all using the same version of some requirement that was defined like 10 years ago. So we can't really migrate to new technologies because we have to coordinate with all the teams and stop innovating. We're going to migrate to this new technology for the next month, and it's a big pain in the butt. Interestingly, back in 2002, Jeff Bezos, he lives around here, he issued a mandate that everyone needs to expose their data and functionality through service interfaces. And they must communicate using these interfaces. No other type of communication is allowed. The only type of communication is using network calls, using via those service interfaces. And it doesn't matter what type of technology anybody uses. Anyone who doesn't do this is fired. Yeah. So, as you can guess, everybody kind of listened if they wanted to stay employed. And they go from this. Sorry for my crayon drawings, but I think it explains. This is a monolith, and there's 2 people working on it. And now there are 2 servers, and people are deploying their code to their own server, and they're autonomous, and they're very happy. They're not fired, and any kind of communication is done on the network. Interestingly, though, if you were to Google and look at various microservice diagrams, you'll find that there's this big chunk on the very top where the front end is. And all the teams, they broke into these little autonomous microservices, and they still kind of integrate this gigantic monolithic front end. And that doesn't really work. If we really want autonomy, we need to do it end to end. We can't just stop before we get to the front end. We need to kind of extend the idea of microservices from the back end all the way to the very, very top there, the browser, which is the last integration piece. Cool. So let's talk about how we can do that. We're going to talk about vending experiences. And I say vending experiences because a backend would vend data, whereas a front end is going to vend an experience. To do that, kind of rethink how you would approach designing a web app or a UI, rather than creating one big website or a page. It's a composition of features owned by different teams. And they own these features from end to end, from database to user interface. We might vend these experiences to multiple consumers, and they might have different types of applications. A very simple version of this might look like this, where I have a client controller that is a custom element. You guys can search web components if anybody's not familiar with that now, but this is a custom element, and I've added a render method where I'm making a call to our service controller for some data. That data is being piped into a unidirectional binding view function, right? Which is pretty common in a lot of libraries and frameworks nowadays. Yeah, that's it. So just to recap, it's a really simple looking web app we're just rendering a fragment though. Does everybody kind of follow what that was? Pretty simple. Cool. To make it useful though, we need to kind of define an interface for consumers to use it though. And there's two types of interfaces we're going to talk about, a query interface as well as an event interface. And in order to interface with us, the provider, we are going to provide a client. And that word's kind of overused. When I'm saying a client, it's just a dependency that our consumers are going to take to use our, to make calls to us, the provider. Cool, so the first one is a render client. It is a interface where we, where we have a consumer who is depending on this client piece, and that client is used to make render calls to our client controller, and that result is delivered to the browser. We allow them to customize those render calls using HTML attributes. And this is specified inside of the render client. The render client downloads a client controller and listens into various attributes that we want to expose in our interface. When those change, we dispatch a new render function and refresh the view right there. We can also allow people to configure our render client or our fragment using CSS hooks, which is a practice where we leverage CSS variables to allow a consumer to define variables and customize the UI. So these are like design tokens, like style constants. If you guys have used Bootstrap, you know they have like border radius or padding large or padding small. So we can expose those using CSS variables and allow a provider to customize the UI. So if we're rendering in multiple different consumers, they can change the look and feel of our fragment for different UIs. The other interface we have is an event client, where this is designed for other experiences inside of the same view. We might want to listen to like various internal state changes. When a user interacts with our experience, we might want to broadcast this state change and let various other fragments learn about that. To do this, we're going to leverage a built-in pub sub called custom events. And if you guys are familiar, have ever used a custom event before? Pretty interesting tool we can take advantage of here. We just dispatch a custom event, provide any kind of details about that state change, and then our other experiences in that view can subscribe to them and do whatever they want with it. We can also provide callbacks or acknowledgments inside of that custom event as an interesting pattern to do various error handling, so the error can be handled inside of our fragment rather than the entire page. And we're bubbling those events, so our client can just subscribe to the window and listen for events to come through there. Now, another big piece of this is composing experiences. And this is where a lot of platforms at Amazon, they're designed in a similar way here, where they have to put multiple fragments into a single view. Doing that is pretty complicated depending on how far you scale it or how complex you want to do this. But there are a lot of components that are common in these platforms. Usually they have some kind of router piece where a request comes into a router, and that router proxies that request to a view composition service. That view composition service has a bunch of layouts in the storage and returns those in the initial request. Then there's a bunch of slots inside of those layout storages. When they get to the browser, they send another request to that router, and that's proxying to the various endpoints of experiences. Now, just because we can do that, just to make sure that everybody understand how it's pretty easy to set up. It's possible to do this. Yeah?
When you're loading the page, does it take longer because you're making multiple calls?
That's a good question. So we can go back to the.
Can you repeat the question for everybody?
Yeah, oh sure, yeah. So when we load the page, does it take longer because we're making multiple calls? So that's a really good question because we're doing client-side rendering in this example, but we can also do server-side rendering, where if we see in that initial request, we can load those server-side rendered fragments inside of the initial response. And these are important ones that we want like above the fold in the initial response. And then we can do client-side ones for the less critical ones. But yeah, I kind of excluded server-side rendering from this talk because we only had 20 minutes to go over. So good question. And also going back here, a couple other components I'm not really talking about, but an asset loader, a lot of work goes into optimizing performance, right? Because we have a lot of code duplication in this federated kind of deployment where teams are, they're not sharing dependencies, so they like often copy and paste things. But we need to reduce those asset sizes using some kind of asset loader. And there's often a component registry that is also a large topic, but it's a piece that allows teams to share, compose fragments within themselves and other cross-cutting concerns. Cool. So now we know how to do it. Let's talk about how we can harden it. We are doing something that's pretty dangerous here. It's a lot harder to test a autonomous or a federated kind of deployment because we're not really aware of our consumers in the context of our pipelines. So we need to take some steps to make sure we're doing this safely. One thing we're already doing is using this unidirectional data binding pattern, which makes our front end much more predictable. We can encapsulate our front end using a shadow DOM. So we can isolate it from like various CSS, global CSS affecting the fragment, our fragment, and prevent our styles from leaking out there. We can set certain constraints around performance. So if we want to say that like assets need to be this size or else we're going to alarm, we can prevent fragments from doing that. We can also implement a circuit breaker. This is just a switch if everything else goes wrong. We can flip the switch and turn off our front end so we don't break the rest of the experience. This is useful and we can just render some kind of static for a port page or something like that. Cool. Contracts. Anytime, we've been talking about contracts a lot, but anytime a interface or a consumer is coupled with a provider interface, that's a contract. And that integration exists in that render interface. So anytime we need to render our fragment a certain way, that's a contract that it's going to be rendered that way. Oops. That event-based interface, that's also a contract. It's a contract that exists around the structure of the events, especially the data structure of the event details. We also have some sort of composition contract. So how much space is my fragment going to take, or how tall, or how wide is it going to be? Because we can't prevent it from influencing the rest of the view there. And we want to make sure if we say it's going to be this wide, that it will be this wide. If it can be shrunk this much, it will be. Without the help of end-to-end tests, we can start implementing this practice called contract testing. Really, we just want to test these integration points. If we were to use like some sort of end-to-end test or do an integration test between teams or fragments, in our pipeline, we would have to consume, or we'd have to take a dependency on all of the other, whatever other consumers. For each one of our consumers, we'd have to take in all of the providers it's using, or vice versa. If I'm a provider, I have to pull out all the dependencies of a consumer. And you get this really kind of crazy, complex situation, which makes it very difficult. But if we can just isolate those contracts and write tests in a way that doesn't require we take all the dependencies, we can remain autonomous. So a client contract is used to power is defined by the client we were providing earlier for our consumers to use. So any kind of rendering and event-based interfaces are used to define that contract. And that contract can be used as input to create a mock consumer and a mock provider. We can use the mock provider in some kind of test level situation inside of the pipeline that is used by the consumer pipeline, without creating a dependency on a provider. And alternatively, we can use some form of consumer contract testing to to simulate a consumer making various calls to a provider. So in the consumer contract test, we are just sending requests to the provider and expecting a certain result to be a certain way. We can assert that it's this way. In a cool practice called consumer-driven contract testing, we allow consumers to actually write their own contract tests, and they provide that to the provider to run in their pipeline. And this is really powerful because we can get an accurate idea of what our consumers need for an interface. So we can use it to drive our interface design and thus help us make a robust API. We're not exposing endpoints that we don't need to expose. This is Postel's law, we don't do extra endpoints that we don't need to. So this is really only the tip of the iceberg. There's a lot of information in 20 minutes. There's a lot more work involved around authentication, creating a cohesive and consistent UI, performance, composition, and handling cross-cutting concerns. So that said, autonomy, it's interesting, there's a lot of implications here. So I want to kind of hear from you guys. What do you think? Do you think it's possible for us? Yeah? Potentially. The reason I ask is this has a lot of implications. This might not be relevant to you. Because a lot of people are fine with a monolithic style architecture, but if we do this, it becomes very interesting. We can deploy our front ends in a way that we don't need to release them all together. So we have a bunch of little tiny pieces on the page, and everybody can just be updating without creating a version. Yeah.
I think it's very dependent on the human scale of the organization. So like in Amazon, you got like 1,000 teams.
Yeah.
Then makes all the sense in the world to absolutely do that. If you're like a startup with 8 people, you should absolutely not even consider doing this for the next 10 years.
It's a good call out. There's actually a phrase called microservice envy. It was trending on ThoughtWorks. Yeah. So I'm trying to actually promote some micro front-end envy so we can get people involved in open source and we can start getting more support for this. But it's a trick. You're right. Not to fall for it.
It's like Kubernetes is a similar sort of thing.
Yep.
It's very cool in organizations that need it or that need containerization in that way.
Mm-hmm.
But for most organizations, it's probably a mistake. And yet, all the cool kids are doing it, so everybody wants to do it.
Yeah.
So you've got like 20-person teams with 40 services, and then you got 3 or 4 services that you're responsible for maintaining yourself. And
Interesting. So a counterpoint I heard, it was a VP of Spotify. So if you're not familiar, Spotify has a federated system as well, and he left Spotify, and they're doing a startup, and he's starting with this kind of micro front-end model. And his reasoning is that once we create a monolith, we know the scope of our product is eventually going to get a certain size. If we build it in a monolith, it's going to be very expensive for us to start breaking it down later. So he set a lot of the infrastructure to do it earlier. So that said,
the advantage there is that he actually has the professional experience of working in an environment that's done successfully.
Yeah.
And you have that.
I think that makes sense. Or if you can just convince somebody in business that you need to do it this way because you like it, but you don't tell them that. Yeah. Is there any, hey.
How do you handle cache busting as these clients are updating their code base? How do you ensure that the consumers are actually pulling it in?
Cache busting? So you asked how do we ensure that we're properly busting our cache? I don't know if that's a phrase. We're gonna bust the cache. It's a great question. So they all have relative endpoints. I don't want to jump back through a bunch of slides, but we can do versioning in the requests. So we can specify a version, and we can bring the cache that way. But that's one way. There's multiple ways to do it. It's not terribly different between one or another.
You mentioned asset management and shared assets.
Mm-hmm.
How do you manage that as far as versions go? Like, if you share an asset, does everybody have to be on the same version? If versions drift, do you have to build multiple versions of the same asset?
There's a lot of different ways. So in Amazon, there's teams that do handle this different ways. That's a really great question, though, because they spend a lot of time writing designs about how to do this. And there's actually quite a few ways. So it really depends on what your requirements are. So if you want to, one way you can do it is say you have your shared assets, you have a component library or component team, right? They just manage various component library, and we want all our front ends to use the same component library. They might provide that component library in runtime inside of the main application, and they just don't version anything. So they're always releasing the latest version into the front end, and everyone's just using that. And we're all keeping our fingers crossed that they don't do something crazy, which hasn't happened yet in that situation. I don't know. But in another way, we can host, so depending on what type of, what do you say, cross-cutting concerns we have, if they are, like another experience that's connected with data, services in the back end, you would want to do some kind of deprecation if you wanted to break your contracts. So just like you would in a microservice world, once you create a contract, once you design that API, you got to be really careful, because if you want to deprecate one of those fields, you're going to have your consumers migrate. So you would, in that situation, would have 2 versions hosted until everybody migrates off, and do some kind of web lab, I don't know if that phrase makes sense to people, where you slowly start to dial up until everybody's moved off into the new version. But it's a really great question, and a very large topic that you can spend a whole talk speaking about. But yeah, happy to talk to you more about it afterwards. Any other questions? Yeah?
Is there like a central committee that's mediating between all these microservices and just kind of taming the chaos, or how does that work?
That's a good question. Microservice committee. There are like frameworks designed to create a little bit of consistency without compromising autonomy. But for the most part, it's very, very loosely defined. I think that was a mistake that earlier service-oriented architecture made, where they built, very, very large pipes, and they had, this very large integration pieces, and we learned we want to keep it as thin as possible. So there's actually not a big committee. There's processes for, yelling at people if they break a contract and getting them in trouble. Yeah. Anybody else? Those are all really good questions. And yeah, I should say also, if you guys want to talk to me afterwards, I'm a lot more social with a beer. So feel free to buy me a beer and ask me some questions. We're also hiring at Amazon. If you find this topic interesting, definitely, let me know. And there's a ton of teams that could use your experience. So yeah, thank you everybody for your time.